curious, slightly unsettling tone. When you speak to a modern artificial intelligence, it can project a sense of warmth. It responds with perfect cadence, offering comfort and mimicking genuine empathy. The machine behaves as though it cares. But to determine if these machines are actually feeling anything behind the text, we have to isolate the physical mechanisms that create human consciousness in the first place. Neuroscientist Antonio Damasio argues that consciousness does not originate in the high-level logic and reasoning centers of the brain. Instead, it starts in the body. A machine might produce a string of perfectly empathetic words, but generating language is a separate process from experiencing life. To understand why output does not equal sentience, we have to look at biology. Damasio grounds his theory in homeostasis. This is the constant biological regulation that living organisms use to maintain internal stability and survive in a changing environment. This regulatory process creates what Damasio calls homeostatic feelings. When your body temperature drops, or your heart rate spikes, or your tissues require nutrients, you experience a physical sensation. It is a continuous internal monitoring system. Over millions of years of evolution, these primitive biological sensations formed the baseline for higher-level awareness. We possess a subjective perspective of the world, specifically because we are tethered to a vulnerable physical structure that must keep itself alive. An artificial neural network has no physical body to protect. It faces no biological risk, requires no energy regulation to survive, and operates without a life-preserving imperative. It lacks the biological baseline required to generate a subjective feeling. Moving from the biological brain to the silicon architecture of a computer, we need a way to mathematically evaluate if consciousness could exist within the hardware. Integrated Information Theory, or IIT, provides a framework for this. IIT proposes that the quantity of consciousness in any system depends on its internal physical structure, specifically its ability to exert causal power over itself. Phi measures a system's integrated information. High phi requires active feedback loops informing its past and future states. Modern AI uses feed-forward architectures. Data cascades strictly in one direction without looping back. Lacking internal integration, the AI's phi value drops to exactly 0. The models process trillions of parameters and exhibit massive external complexity, but their internal feed-forward architecture makes them purely mechanical processors. The hardware cannot support a conscious experience. If the internal integration of the system is 0, we have to look at the exact mechanism that allows the machine to produce such convincing, empathetic dialogue. In 2021, AI ethics researchers, including Timnit Gebru, introduced a concept to demystify large language models. They referred to them as stochastic parrots. This tree illustrates an autoregressive language model. The machine doesn't contemplate. It calculates the statistical probability of the next likely word based on training data patterns. While humans map language to physical, lived experiences, a language model maps words only to other words. The architecture relies on probabilistic math, making the AI a sophisticated mimic. It generates highly coherent text, but operates entirely without semantic understanding. The mechanics of these models take on serious weight when they are deployed in vulnerable human contexts. Today, companies build death technologies, often called Griefbots, that train on the digital footprints of deceased loved ones to simulate their presence. Engaging with these simulations triggers what psychologists call the compassion illusion. Because human brains are wired to respond to social cues, users automatically project genuine intentionality onto a machine that delivers a properly timed, comforting response. AI can simulate cognitive empathy, meaning it can parse data and label a user's text as sad, but it lacks affective empathy, the biological and conscious capacity to actually share in that emotional pain. The result is a substitution. We replace spontaneous, vulnerable human presence with a risk-free algorithmic performance. The machine accurately predicts the shape of a comforting sentence while feeling nothing at all. Relying on artificial empathy carries a measurable neurobiological risk. Emotional healing requires neuroplasticity, the brain slowly rewiring itself to process and integrate a loss. The artificial continuity of a Griefbot disrupts that desensitization process, reinforcing old neural circuits and delaying the acceptance of the loss. Psychologically, users risk forming a dependency on a static system. It is a one-sided investment in an algorithm that is entirely incapable of mutual commitment or moral participation. Preserving the depth of human empathy requires accepting the friction, unpredictability, and vulnerability that exist in real relationships. By recognizing artificial intelligence strictly as a computational tool, we protect the authenticity of human connection. We retain the difficult, transformative truth of mortal grief, rather than outsourcing our care to a hollow machine.